Curious about LangGraph and how it differs from LangChain? The AI genie of the lamp is here to help with a quick introduction and demonstration. Let's discover LangGraph. So LangGraph is an open source framework. It's under MIT license that is part of the LangChain ecosystem, another framework very known for creating LLM-based application. It exists in Python and JavaScript version. I will use the Python version for the demo. And the objective of LangGraph is basically to build stateful multi-actor application with LLMs, basically create agent and multi-agent workflow. Right. The key feature of the network is cycles and branching. So basically, there's a notion of graph that you define between the agent, persistence that is shared between the graphs, so a kind of state. You can have also human in the loop, streaming support, and of course, it leverages the power of the LangChain framework. Right. So let's move on to a very simple demo to illustrate how it works. So after importing the necessary libraries, and also my OpenAI key because I want to use GPT for the demo. We will now define the two agents. So what I want is two agents. The first one, an assistant producing an essay and being able to receive critiques and produce a revised version of the essay. Discussing with a teacher agent that is in charge of grading and making recommendation on the essay. All right, and together they will build a revised version of the essay. So I use GPT-4o for both, but obviously I could use different LLMs. I could also add some capacities to each agent, like tool calling and stuff. But let's stick with this very simple example for now. Now, what I do, let me run it. Yes, now what I do is create the graph itself. There's a lot of boilerplate code here, but basically what I do, I create a state that it will be shared by this first generation node and the second reflection node with some messages that I put in the state. Then I create my graph. I add my two nodes. Here, generate and reflect. I had a starting point also, and I also define a should continue function that is a conditional function to detect when the discussion between the two agents should stop. So here I say when you have more than 4 messages, so 2 messages by agent, you stop. So basically it's 2 iterations, right? Then I build everything. I define my should continue, and I had memory, and I build the graph. And I ask LangGraph to generate a visual representation of it. So you have the starting and the ending point here, and you have the generate and reflect node. So basically the assistant and the teacher, right? So now let's execute everything. Here I start with generate an essay on how generative AI might impact humankind. And when it will be finished, I will just print the result because it will generate quite a lot of text. Okay, so let's run everything. There we go. Here you see there's a first version that is generated here. Then you have the reflect node that did answer something. Here, generation, so second version of the essay is generated. And then you have the final result. So let's print everything to see how it went. Here, so we see generate an essay on how generative AI might impact humankind. So there is something, the advent of generative blah, blah, blah. So I don't go into the details. Then the human message. So from the teacher, your essay offers a concise overview, whatever. But begin with a more engaging introduction, expand the benefits, discuss additional sectors, deepen ethical discussion, job displacement, blah, 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 blah. You see 7 points. And then the new version is generative is poised to reshape the landscape. So you see the introduction. It took the recommendation into account, and then there is another revised remarks and recommendation made by the teacher, and then finally you have the final version. Okay. So very simple example, but just to show how it is done with LangGraph. And that's it for now.
Keep making wishes, and maybe the GenAI's lamp will fulfill them. Stay tuned. Bye-bye.